Good morning, everyone. So let's continue our Kubernetes sessions where we have stopped in the previous session. So, hope you uh, understood. We have discussed it so far, like what is pod, and we also understood like what is replication controller. And in the beginning itself, in the introduction part of the Kubernetes itself, I told like we can create various objects in the Kubernetes. So these are the objects. We can create pods, we can create replication controller, we can create a replica set, and we have also seen the difference between replication controller and replica set. And we can also create deployment object. Okay, we can create deployment object, and there are some other objects like ingress. There are some other objects like ingress, and we have also an object called service. We also have an object called service. So we have already covered all these objects, like we know how to create pod, replication controller, replica set, deployment object. And let me give you some clarity on these things. So usually, we had a discussion on all these things, but when we come to the real time, only the deployment object will be created. Why? Because deployment is the high level object in the Kubernetes. So suppose, let's take an example. If I create a deployment, okay, if I create a deployment object, so I will have all the features here itself. So let's go to the pod. If I create a pod, I'll get a single pod. I'll get a single pod. If I go to the replication controller, and it has an advantage where we can increase the number of replicas, where we can create multiple replicas of the same pod. So replica set is having some other advantages where here we have only where we can define only single set of labels, but here we can define multiple set of labels. So that is the difference we have seen like in the replication controller from the replication controller and replica set. And if we look at the deployment, all the advantages we have in the deployment object, like so if I create a deployment object, I can create multiple number of replicas. I can define multiple set of labels. So everything, like suppose if I want 5 pods, yes, I can write an YAML file for the deployment, and I can go ahead and I can define the number of replicas I need. So deployment is the object that will be usually created. Anyhow, we discussed about all the smallest objects, replica set earlier we were using. But today, if we look at the Kubernetes, so usually nobody will create the pod YAML. Nobody will write a specific YAML for the pod, specific YAML for replication controller and replica set. Okay, we are not using those objects because we have all the advantages here in a single object called deployment. So once I write an YAML file of deployment, I will get all the advantages of replication controller as well as replica set. And the deployment object is also have an advantage of deployment object is also having an advantage of rolling update, as we discussed in the previous session. Rolling update meaning, suppose I can go ahead here, I can go ahead and update the image, Docker image. And otherwise, if the current version is not working fine, I can roll back the Docker image. We have seen like how to set the Docker image, how to replace the Docker image, how to replace the existing Docker image. Okay, so that rolling update feature is available here in the deployment object. Like if we want, we can change the version of the image. And if we face any issues in the current version, we can roll back to the previous version. Rolling back to the previous version or updating to the next level versions, everything is possible in the deployment object. That's the reason why most of the times like we use deployment object and we won't go for pod, replication controller and replica set. So this is the object we create in our projects. Like let's come to so once the deployment is created, we also need to create some additional files like ingress, service, all these things. So far we have understood all the things like pod, replication controller, replica set, all these things, right? So these are for only understanding purpose. If we don't understand the small object, we cannot understand the deployment high level object. So we know what is pod, we know what is replication controller, we know what is replica set. Anyhow, we are not using all these things. Okay, why? Because all the advantages we have, all of them having an each and every one is having a specific advantage. So we are finding all the benefits here in the deployment. So once I write the deployment, usually I'll get all the benefits of having pod ML, replica set ML, replication controller ML, all those things. So apart from it, it also has some specific advantages like rolling update, where we can go for updating the images or rolling back to the previous versions. So today, let's discuss about the remaining objects like ingress as well as service. And we also have an object called HPA, horizontal pod auto scaling. We'll also create along with ingress and service object. We also create HPA. HPA stands for horizontal pod auto scaling. Or auto scaling. So by the name itself, we can understand auto scale to increase the number of pods automatically or to decrease the number of pods automatically. We are not going to handle it. We will simply write HPA, and HPA will automatically, okay, will automatically handles whenever the traffic increases. It will increase the number of replicas whenever the traffic decreases. So I'm using the terminology called traffic here. Traffic means the number of requests coming from the outside, the number of people accessing that particular application defines the traffic. HPA stands for horizontal pod auto scaling. So once HPA is enabled, HPA will automatically handles the number of replicas. It will automatically increase the replicas and it automatically decreases the number of replicas. That's how it happens. So let's go ahead and start with ingress first. Let's understand what is ingress. To understand the ingress, we need to understand some flow. Okay, let me show you the diagram to understand the basic flow so that you'll understand this one very clearly. So usually what happens is like, you can look at here, this is our Kubernetes cluster. As I told you in the beginning of the Kubernetes session, I told you like we will be creating a cluster. We know that we will be creating a cluster. So Kubernetes cluster, inside the cluster, we will be creating some nodes. Assume that we have some 3 nodes in a cluster. These are the nodes that we are creating inside the cluster. And inside the cluster, we'll be creating deployment. Okay. We'll be creating ingress object inside the node. Okay. Just assume that we have 3 nodes here. We have 3 nodes here. Consider we are going to create the deployment, ingress, service object, HPA, everything at the node level. We will write everything in the YAML file, and we will create these things in the we will run this YAML file so that these objects will be created. So try to understand why we are writing all these YAML files and why we are creating all these Kubernetes objects. Okay, one is deployment object, ingress, service, HPA, and there are many other objects also. But these are the important objects that we need to understand. Why we are creating all these objects? Let's see the flow here. So usually when I create a deployment, okay, when I'm talking about the deployment object, don't forget that inside the deployment I have the pods running. The number of replicas you specify. Suppose if you specify 3 replicas, 3 replicas will be running inside the deployment. 3 pods will be running inside the deployment. If you specify 4 replicas, 4 pods will up and run in the deployment. This is a deployment file. Inside the deployment, I have pods. Okay. Just assume that. Okay. This is the deployment that I'm creating. And inside the deployment, I have the deployment file. I'll specify I need 4 replicas. So that 4 replicas will be created. If I specify 3 replicas, 3 replicas will be created. And consider this is an ingress. Okay. This is an ingress object. So we haven't any idea. We don't we are not yet discussed about the ingress object. We will discuss now what is ingress and what is the what is the reason why we are using this in the why we are creating this object and all. And apart from the ingress, we also have the service object. Apart from the apart from the ingress, we also create service object inside the node. And apart from the service, we also create HPA. HPA stands for horizontal pod auto scaling. Simply, I'm calling it as, in a short form, I'm calling it as HPA. HPA stands for horizontal pod auto scaling. Let's understand the specific advantages of each and every one. Look at the diagram here. Usually what happens, these are the pods, okay? Pod 1, pod 2. Consider in this example, in this, look at the diagram. In this particular diagram, we have only two pods, pod 1 and pod 2. And you see the communication happening here, how the communication is happening here. So these two pods, assume that these two pods are in the deployment. Okay, these two pods are in the deployment. So anyhow, to see here, the pods are outside the deployment. So usually what we will do is we will create a deployment, and inside the deployment, the pods will be running. So I'll write a deployment YAML file. I won't write pod YAML. I will write deployment YAML, and inside the deployment YAML, I'll specify I need two replicas, so the two pods will be created. So once the pods are created and pods are up and running, usually how we are accessing the pods? How we are accessing the pods? We are accessing the pods. We are accessing the pods from the service object. You see, look at the diagram. We have two pods running. Consider two pods running here. And if I want to access the pods, these pods can be accessed by using an object called service. And this service object can be accessed by an object called ingress. And this ingress, see, all these components are inside the cluster. Ingress, service, pods, everything, all these things are inside the cluster. And if we need to expose this thing, okay? So to the people who are accessing from outside the cluster, to the client. Client is nothing but the public, okay? Who is accessing your application from outside the cluster. Okay, in this diagram, it is very clear. Client is nothing but a person who is accessing your application from outside the cluster. If he wants to access the pods, he cannot access the pods directly. So usually how actually the flow goes is the client will interact with the load balancer. Client will interact with the load balancer. And here the load balancer is named as the ingress managed load balancer. Okay, so I'll discuss with you about this load balancer later, but try to understand. Client cannot directly interact with the pods which are running inside the cluster. First, the client request will goes to the load balancer. From the load balancer, the request goes to the ingress object. From the ingress object, the request will be diverted to the service object, and the service object will select the pods. Service object will access the pods. Okay, through the service object, he is going to access the pods. The request will be this service object. Okay, the service object will be accessing the pods based on some port number. Okay, try to understand the flow once again. So what is happening here? If anyone wants to access your application which is running inside the Kubernetes cluster, your application will be running inside your application will be running in the form of pods. Assume your application is running in the form of pods. If anyone outside the cluster wants to access your application which is running in the form of pods, they won't directly access. They will not directly access. They cannot directly access your pods. So the process that we follow here is the client request will goes to the load balancer first. From the load balancer, the request will be going to the ingress object, and the ingress object will route the traffic to the service. The service object will route from the service object. The traffic will be routed to the pods. This is the flow actually. So you might understand now what is the importance of creating the ingress object and service object. The importance of creating the ingress and service object in Kubernetes is, so without ingress, you see what the importance of ingress object is. We are we are exposing the traffic. With the help of this ingress object only, the traffic is exposed to outside, meaning the ports are exposing to the outside. Suppose if any client wants to access our application, which is running inside the cluster, definitely we are using ingress. So client will sends the request to the load balancer. Okay, whatever the request that is sending by the client, that will goes to the load balancer. So from the load balancer, the request will be received by the ingress object. Ingress will route that same traffic to the service. Service will Service will be routing the traffic to the pods. This is the flow. Let's understand the ingress object in detail. We need to understand the ingress object in detail. How the ingress AML looks like. Okay, how actually the ingress AML looks like. All those things we'll understand now. So you can go to the Kubernetes documentation, where we have an official documentation for Kubernetes, which is called Kubernetes.io, Kubernetes.io. And you can search for the ingress. So just click on the ingress. Just click on the ingress and so you can see here this is the AML file. Okay, this is how the AML file looks like for the AML for the ingress object. So as I told you, every AML in the Kubernetes will be having the same specific format like API version, as we discussed in the earlier sessions. API version, kind, metadata, and specification. All these things are common. API version, kind, metadata, specification. All these things are common. And you see the API version that we are using for the Kubernetes, it is different. Networking.k8s.io. Networking.k8s.io/v1. This is the API version that we are using for this Kubernetes, for this ingress object. Anyhow, kind, the name of the object we are creating is ingress. Metadata is the additional information. Metadata is the additional information about this ingress object. And in the specification, we are going to specify, under the specification section, we are going to specify how actually the request will be diverted. Okay, we need to understand. Okay, before we understand this YAML, I'll let you know the flow of, I just wanted you to know the flow actually, how actually it works. Okay, you see here how it works. So whatever the request that comes from the outside, you see, can we see here we have some components like what is happening here. So first the request will be received by the ingress controller. Whatever the request that is coming from the outside, the request will be received by the ingress controller. Ingress controller is another object. Okay, ingress controller is another object. You can look here. I'm showing you in the diagram also. As I told you. So the whatever the request coming from the outside, it will go to the ingress managed load balancer. It is nothing but our ingress controller. First, the request will goes to the ingress. This is the ingress controller. Ingress object is different. Ingress controller is different. Okay, ingress is different. Ingress controller is different. So first the request will goes to the ingress controller. From the ingress controller, which is, see, we are naming here like ingress managed load balancer. Our ingress controller is also called as the load balancer. Our ingress controller, what's the ingress controller, what I'm saying. So that ingress controller will be called as a load balancer. So request will goes to the ingress controller. From the ingress controller, it goes to the ingress object, right? From the ingress, it goes to service. From service, it goes to pods. The same thing you need to understand here. The request comes from the outside that will be received by the ingress controller. Okay. And when a request comes to the ingress controller, when a request comes to the, one second. Okay. So usually what happens, you see here, the request comes from the ingress controller to the ingress, right? So once the request is received by the ingress, okay, once the request is received by the ingress from this load balancer, from this ingress controller, okay, I'm using two terminologies here. One is ingress controller or load balancer. The client sends, whenever the client sends a request, first the request will goes to the load balancer or ingress controller. From there, the request will be moving to the ingress object. Once the ingress object receives the object, receives the request, we are trying to understand how what actually the ingress is doing here. What actually the ingress is doing here. So the ingress, the actually what the ingress is doing is the ingress is routing the request. Okay, the ingress is routing the request from the ingress is routing the request to the service object. What is the responsibility of ingress object? It receives the request from outside load balance. It receives the request from the load balancer. Ingress receives the request from the load balancer and routes the request to the service object. That's what it is doing. That is what it is doing. It is receiving the request from the load balancer or ingress controller, and it is routing the request to the service object. In the same way, you look at the YAML file also. In the same way, you look at the YAML file also. This is the YAML file, okay? API version, we have kind, metadata specification, all these things. Anyhow, the API version that we are using here is this one, networking.kits.io. This is the ingress type of the object we are creating. This is the additional information about the ingress object. Under the specification, we are going to specify some rules. We are going to specify some rules. Okay, what are the rules here? What is this ingress class name? So this ingress class name will defines the name of the ingress controller that handles the request. The name of the ingress controller that handles the request. Right? So you can see here. These are the rules that we are specifying. So the main objective of this rule is like, I told you what ingress is doing. Ingress receives the request and forwards the request to the backend, which is called service object. Nothing it is doing. It is receiving the request on some path and forwarding the request to the backend on some port number. Okay, the rules here under the specification section, we are specifying some rules. The meaning of this is it is going to receive the request on some port number, like on some ports, particularly like HTTP or HTTPS. It receives the request on some ports and it forwards the request to the backend like service. It forwards the request to the service object. That's what I'm saying. Ingress receives the request from the ingress controller on some port number called HTTP, and it is going to forward the request to the service object. It is going to forward the request to the service object. That's what it is doing. And what the service object is doing, you see here, what is the service object? What is the main objective of service object? We see the main objective of service object is, look at the diagram here. The main object of service object is service object will route the traffic to the pods. Service object will routes the traffic to the pods. So let me open the service YAML also. What is happening in the service object? In the service object, the main objective of service is it will routes the traffic to the pods. Okay, it will select the pods. You see here also the same format, API version, kind, metadata, specification. The service object will select the pods which are named as my app. It will select the pods which are named as my app which are named with a label called my app, and it will route the traffic to these pods. It will route the traffic to these pods. Hope you are getting like what actually is happening here. Okay, leave about all these things. Try to understand the concept first. Okay, try to understand the concept first. So this is the main objective of the ingress object. We are creating ingress dot we are writing ingress.aml. The main objective of writing ingress.aml is like it will receive the traffic. It will receive the traffic from outside the load balancer. It will receive the traffic from the load balancer, and it will route the traffic to the service object. That's what we are writing in the AML file also. That's what we are writing under the specification section. Here we have a rules. What are the rules we are defining? So if the request comes, it will receive the request and it will forward the request to the backend. What is the backend? Backend is service. Backend is service. And what is the service is doing? The service object, the service object will receive the request. Once the service object receives the request, it will forward the same traffic to the pods, which are named with the labels called my app. So the service object is having a selector. Under the selector, we are mentioning the pod names. So if the pods are labeled with the name called my app, so the traffic will be diverted to these pods which are labeled as my app. That's how the traffic will be diverted from where? From here. From here, from the client. Okay, from the client. So what happens? Suppose if the client sends a request, assume that this is how the request is. This is how the URL is. Consider I would like to access the website called example.com, google.com, something like that. Okay? Anything you can assume. I'm just taking an example. Okay. We are going to access a particular website called google.com or example.com, facebook.com. Okay. So this is the website actually I would like to receive. And inside this, so this is an application actually. Okay. Google is consider we have Facebook is an application. Okay. Facebook is an application. Under Facebook, like we will be having many pages, many services. Under Facebook, we'll be having many microservices. Under Facebook, we'll be having many microservices. Consider this is the domain that I would like to access. Usually what happens is, okay, usually what happens is the request comes from the client. The request will goes to the load balancer first, which is called ingress controller. Ingress controller will receive the request. Try to understand. The ingress controller will receive the request. And the controller, once the ingress controller receives the request, it will match with this path. You see here, it is trying to, the request is for test path. The request is mainly for test path. It is trying to access test path. And in the AML file, you can see here, it is trying to access, this is the path that is requesting for. It is trying to access the request. We are trying to access the request of this one, /test path. Okay. So once it understands, okay, it is requesting the path like /test path, then it will forwards the request to this service. Again, service, we have an AML for service. So service will receive the request, and under the service, we have a selector. We are specifying that pods are running with a table called my app, so that it will divert the traffic to these pods. If any pod is running with my app, the traffic will be diverted to these particular pods. This is how actually the request will be diverted. This is how actually the request will be diverted. Based on this diagram, you need to understand how actually the request will be diverted to the pods in the Kubernetes cluster. So the ingress exposes HTTP and HTTP routes outside the cluster to the services within the cluster. This is the main point that you need to understand. It receives the requests coming from the outside and routes the request to the service object and routes the request to the service object. Got it? It is receiving the request and routing the request to the service objects. This is what the service ingress object is doing, and we also understood like what is service what does the service object is doing. And let's understand, if you see this example scenario I'm trying to explain, if the domain, if the particularly if the client is sending a request, if the client is sending a request to this path, okay, usually we will be having some microservices. Okay, assume that we have some paths. Okay, we have some paths. We will be writing microservices. You understood like we'll be having some microservices. So consider this is the test path. Okay, assume that we will be having many other paths also. So we have test path one. Okay, so let me show you some example to understand this one. We have already have an ICICI example, ICICI Bank. Let's take an ICICI Bank example. So you see the uh, website name. Okay, you see the website name here. The domain name is icicibank.com. When I just click on the accounts, okay, when I just click on the accounts, it is going, you see, okay. Otherwise, you see icicibank.com, and we are able to see, I'm just clicking on personal. I'm just clicking on personal, and you see I'm just clicking on NRI. Are we able to see the change in the address here when I'm just clicking on personal? Can you see here personal? You can see here. I'm just clicking on the personal page. And when I click on the NRI banking, I am getting NRI banking. And when I just click on business, I'm getting business banking. And when I click on corporate, usually I'll get corporate banking. Can you see? Okay, you don't need to actually we don't need to actually give. So I'm just going to the browser like ICICI banking. Okay, try to understand ICICI banking slash ICICI banking slash business. Are we able to see the business account? Directly business banking. Okay. If I give icicibank.com slash business banking, I'm directly going to the business banking page. Similarly, okay, NRI banking will be having some name NRI banking. Let me remove this one and let me try icicibank.com slash NRI banking. So you need to understand the request, how the request is coming to the ingress object from the outside. Try to understand. Okay. So I'm just taking an example like icicibank.com. Okay, icicibank.com slash NRI banking. This is how the request comes. If the client sends a request to icicibank.com, usually from the icicibank.com, the request might goes to the NRI banking, and otherwise we also have some other like business banking. There will be some microservices. As I told you, each and everything will be written as microservice. Each and every microservice will be deployed. Each and every microservice will be deployed once This is how the request will be moving. Okay, suppose if the domain is www.icicibank.com and assume that NRA banking is microservice, each and every microservice will be deployed. So we are deploying the services. We are deploying all the microservices in the Kubernetes cluster. NRA banking is one microservice. Business banking is one microservice. Based on microservices, if we are deploying the services in the Kubernetes cluster, so each and every one will have a deployment file. NRA banking microservice will have a deployment file. NRA banking will have an ingress object. NRA banking, each and every microservice. Okay, if NRA banking is a microservice, each and every microservice will be having, try to understand. If NRA banking is a microservice, each and every microservice will have a deployment. We are going to create deployment object for NRA banking. We are going to create ingress object for NRA banking. We are going to create service object for NRA banking, and we will be enabling HPA. We are writing HPA for NRA banking. All these things we are doing for each and every microservice. And if suppose there is another microservice called business banking. For business banking also, we'll be doing like in the same way. Okay, we'll be having deployments, separate deployments. We'll be having a separate deployment, ingress object, service object, HP. All these things are we are creating all these things for individual microservices. So now when the request comes, okay, when the request comes, sorry. So if the client sends a request to the NRI banking, the request will go first. The request will goes to the load balancer. Load balancer, which is called as ingress control. As I told you, the request will goes to the load balancer first. If you look at the diagram, you can understand the request will goes to the load balancer. From the load balancer, the request will be forwarded to the ingress object. Okay. So you look at this example. One second. Okay. So based on the request will move to the ingress object. Ingress. So this is the path. So I'm keeping like the test path, right? So you can assume this NRI banking is the test path here. NRI banking is the test path here in this example. Assume that, okay, the path is the NRI banking. If the path matches to the microservice, that microservice ingress will receive the request. Okay, ingress, there is a component called ingress controller, I told you, which is called as load balancer. So first the request will go to the ingress controller. If anyone is accessing with this URL, okay, if anyone is accessing with this URL, which is called, if anyone is accessing with this URL, www.icicibank.com NRA banking, if anyone is accessing with this URL, okay. You can see here. If anyone is accessing with this URL, first this particular URL, okay, first the request will go to the ingress controller. And you see based on the path, here the path is NRA banking. So it should be, the request should be diverted to the ingress object of, first the request will goes to the ingress controller. And based on the path, you see, which is also called as the load balancer. I'm just saying that. So here usually the name of the ingress controller will be Nginx. The name of the ingress controller will be Nginx. So Nginx ingress controller is the load balancer here. First the request will goes to the load balancer. From the load balancer, based on the path, the request will goes to the ingress object. Based on the request, the path will goes to the ingress object. Okay, this is the ingress object as you see. We are clearly explained. This is the ingress object. This particular ingress object will receive. This is the ingress object. This particular ingress object will receive the request and process the forwards the request to the service object. Hope you are clear how actually the request will comes to the ingress controller, and from the ingress controller it goes to the ingress object. From the ingress object it goes to the service object, and from the service object the request will be forwarded to the pods. So this is what I would like to explain regarding the ingress object and service object, and we also have another object called we also have another object we also have another object called HPA. Let's understand what is HPA. HPA stands for horizontal pod auto scaling. So HPA will also see everything will be written in the form of YAML file only. So what is this HPA will do? HPA will scale up the pods or scale down the pods. So if the HPA is enabled, based on the load that is coming, based on the incoming load, if it is getting more load, HPA will increases the number of pods. If the load is getting decreased, HPA will decreases the number of pods. So while creating the HPA, we will specifically mention the number of, see here, we are HPA AML, we need HPA AML to discuss. Usually HPA can be enabled by with the help of YAML file or otherwise. Yes, here, while creating the HPA, usually whenever we create HPA, everything will be based on, you see here, API version, kind, metadata, specification. The format is same. The YAML file format is same. So these are the things that are very important to understand in the HPA, minimum replicas and maximum replicas. And while creating the HPA, we will give like minimum, we'll specify the minimum replicas and maximum replicas. If the minimum number of replicas are one, always one pod will always be there and up and running. One pod will always be there. And if the maximum replicas are 10, whenever the load increases, whenever the traffic increases, the replicas will be increased to a number of 10. It will not go beyond the number of 10. It will not go beyond the maximum replicas of 10. Why? Because we are clearly mentioning the maximum replicas as 10 only. We are mentioning the number of replicas, maximum replicas as 10 only. The minimum replicas as 1 only. So always one replica will be running. One pod will be always running. And you can also see here the maximum replicas that we are specifying as 10. And if the load increases, the number of replicas will goes to the 10. So based on which metric the replicas will be increasing, you see here we can give either the metric as CPU utilization or either the CPU utilization or otherwise memory as the utilization. What do you mean by CPU utilization? So usually the CPU increases, the CPU utilization increases whenever the load comes, when more request comes. So if the multiple people accessing ICICIbank.com, usually the load will be increases. Whenever the load increases, the CPU utilization of the server will also increases. Whenever the CPU utilization increases, definitely we are enabling HPA based on the CPU utilization. So this HPA will continuously monitor what is the CPU utilization. If the CPU utilization increases, okay, we are just keeping the average utilization as 50. If it goes beyond 50, average utilization means of all the pods running. If two pods are running, it will consider the average CPU utilization of both the pods. Suppose if one pod is consuming 60%, say one pod is having 60% of utilization, another pod is having 30%, 60 plus 30 divided by 2. So 90 by 2, it is 45. It won't go for creating one more replica. If the average utilization reaches to 50, then only it is going to increase the number of replicas. So this is how we are mentioning in the ML file. We are giving minimum number of replicas, maximum number of replicas, and we will also specify based on what metric the pods should be increases. The pod should get increases. Based on what metric the CPU utilization increases. All these things we can understand with the help of this. Okay, we can look at here and we can understand these things. Okay, minimum replicas, maximum replicas, metrics. Based on these things, we're enabling HPA, and HPA is working based on these metrics we are specifying. If this is not the metric, usually most of the time, 90% we use the metric as CPU utilization only. And we can also use memory utilization as the metric. We can also use memory utilization as the metric. Okay, that is another thing. So this is what I would like to explain today. Thank you all. Let's meet in the another session.